Test.
Hello. Hello. Do I sound like I have words coming out of my mouth? I sound incredible. Beautiful. I identify as beautiful, stunning, and immaculate. Thank you. Hello, everyone. We're about ready to get started, so go ahead and make your way over to the stage. Thank you for coming. Hello, everyone. Thank you for coming. Go ahead and find a seat. Feel those vibes from the curated playlist that we got. Ooh, Greg. Hey, Greg. Bro. Okay. Welcome to DEVx. Glad you guys are here today. Yeah, go ahead and clap if you want to. Thank you, everyone, for coming. We are a community of like-minded developers and software engineers in San Diego. Our goal is to bring people together to learn from each other regardless of skill level and to create great developer experiences. And these are our organizers. AJ, Tristan, Sam, Zane, and Ezekiel. Shout out to Ezekiel. He just joined the team. Go ahead and snap if you wish. Brother Ezekiel. And thank you to Edge for hosting, which Sam will talk about right now.
Check. All right. That's good. Can you guys hear me? Can I use that one? This one. Thanks. Hello, everyone. Thanks for coming out. I appreciate. This is quite a crowd. This is probably the biggest one of the year. So yeah, thanks for coming, guys. Just want to let you know about Edge really quick. They're hosting this event. This is Edge HQ, this office. Yeah, so big shout out to them. Thanks to them. I want to give a quick round of applause to Edge. Edge is a pretty awesome kind of community-focused crypto company here in San Diego, based in San Diego since 2014. What we build is basically a crypto app Allows you to buy, sell, exchange, swap, do all the cool things you would want to do with crypto. But more importantly, it's focuses on privacy and self-custody. So you own your own keys. Nobody knows what you're doing with your money. It's your money. It's your keys, your crypto. So just want to let you know about what we do. Also, more importantly, what I like to mention, and full disclaimer, I work at Edge in case you don't already know. What I love about Edge is they're 100% open source. So you can check us out at github.com/Edge app, our whole org there. We have like the GUI, the backend, all that good stuff, all open source for you guys to look and peer through and even contribute if you guys are interested. So come talk to me if you want to do any of that. Another quick note is that Edge is hiring. So if you guys, we're hiring a senior software engineer. So if any of you are looking for a role in crypto, fun space to be in, also come talk to me later and I'll shoot you the details. That's it. So yeah, thanks.
Thank you, Sam. So, a couple of notes. We have Wi-Fi. The name is Edge Guest, and the password is I like big bits, all lowercase. There are restrooms down the hall and to the left. There shouldn't be a code, but if there is, it would be $15.95. And yeah, we have some upcoming events once a month and some more. Please subscribe to our Luma calendar at lu.ma/DEVxSD. We're also hosting on Meetup too, but we prefer Luma. You can also go to DEVx.network to find out what we're all about. There's also LinkedIn at linkedin.com/company/DEVxSD. So go ahead and give us a follow, post something fun. And here's the agenda. So networking lunch, we did that, check mark. And now we're going to do speaker presentations for about an hour. And afterwards, there's a community announcements where you can get up and, I don't know, maybe you have a cool project idea. Maybe you want some people to come to your meetup, whatever. Just get up and we'll hand you the mic. And after that, it's networking, more hangout, and eat the rest of the pizza, please. And then we should close at about 4 p.m. Now, we have a great list of speakers today. Forging Productive National Discourse with React by David Friedley first. Then Arcane, a agentic AI framework for makers by Keith Chester. And finally, Make Your Own AI Images by Ezekiel Lopez. And with that, would everyone welcome up our first speaker, David Friedley?
The mic is green. Cool. All right. Is this thing on? Okay. Oops. Okay. So I'm here to talk about forging productive national discourse online with React. And this is, they told me 20 minutes, I have to leave time for questions, so this is really condensed. I'm David Friedley. I'm part of a nonprofit called NCIV, and this is open source software. The tool is called, or the repo is called Civil Pursuit. And we're just diving in, but I want to say I am so happy to have in-person meetups again, and I want to thank Edge and everybody for putting this together. It is just great to have in person. So, all right, so let's start with the problem, and I'm gonna kill you a little bit with PowerPoints, but not too much. We live in a polarized echo chamber. with the way that social media works and even the news media, we have basically the blues are talking to the blues and the reds are talking to the reds, and the reds are saying not so great things about blues, and the blues are saying things that piss off the reds, but they don't hear each other because we live in a polarized echo chamber. And I want to tell you that in person, dialogue and deliberation works. This is like a social science. They get people together, take a big room full of people, and they can lead them through productive discussions about things they disagree on. And in the end, they understand each other better, they get along, nobody kills each other, and sometimes they even find awesome agreements. And so I'm going to, I guess, take you through some of the steps of one of the very simple discussion formats that they have in dialogue and deliberation. And then I'm going to show you how that turns into code and React. And I'm also going to talk a lot about Storybook today, which has been really instrumental in making this work. So take your room full of people and break them up into small tables. Now, some people will say 8 or 6 or whatever. I like 10 because that makes the math easy, but it's really just a variable. And the first step in this is we start with a question, what's the biggest problem in this country? And we ask everyone to write your answer down first. Don't listen to what other people have to say, just write down your answer. And then we have a step of discussing an answer, discussing answers and putting them into groups. What are the similar answers? Some people might say healthcare, somebody else might say medical care, but it's really the same category. And they're all doing this in person on around tables, and these are supposed to look like Post-its, by the way. And then the next step would be to rank the answers. What's most important for the whole world to consider, and what's least important, as far as you're concerned. All right, and everybody does this sort of individually. And now online, you see a lot of tools where it's like, oh, you can sort them. You can have number 10 and number 9 and number 8. Well, that is a higher cognitive load than saying, well, what's most important and what's least important and what's everything else. So in person, they do it like this. They don't ask you to sort it by 1 through 10. And then the next step is around the table, and this is, we'll get into this more, but it's now discussion time. So there's a question like, what's the most important topics for the table to report out to the rest of the community? And so they'll go around and they'll say what they think is important, and they'll say why. And it's also a good discussion when you're getting other people to say, well, why that's less important, and maybe something else is more important. But there's this discussion step where everybody is expressing what they think productively. And then the next round in this discussion, and the last round in the in-person discussion, would be to rank things again. Now that you've talked about these issues and had your discussion, again, what do you think is the most neutral and least? And surprisingly or not surprisingly, we see convergence. When people do this, they converge on similar things. All right, then what we're doing, because we're online and not in person, we're adding this tournament process where we can invite 1,000, 10,000 people to our discussion and have them go through this discussion process. And then we can take the top 10% of answers from that round and feed them into round 2, where people consider 10 at random of those 1,000 answers. And then round 3, consider those, and round 4, and basically converging into one answer. And the other anecdotal thing about in-person dialogue and deliberation is that sometimes somebody figures it out, how to tie it all together, and you end up with something that 80% or 90% of people agree on. It's not like 51-49. It's like we're looking for the big agreements. All right, so now let's jump to how do we make that work. And so we took all this and we worked with a designer, and we created a Figma layout for all of this, for working with the cards and everything. I certainly don't have time to go through all the Figma, but I want to take you to what we did for the discussion. And so here's the discussion step where we ask everybody, well, why do you think that's most important? So for the things that you thought were most important, just say why you thought it was most important, and also why you thought it was least important. All right? And then we have another step where we show you what everybody said and sort of the side-by-side comparison about why it's important and not. And you can basically pick on the one that you think is the best argument for why it's important, and also the best argument for why it's least important. Now, what I've learned is that you're working with a designer. I mean, it took a few weeks to do this with the designer, and then we turned it into a bunch of GitHub repo issues for different volunteers to work on. And one designer and a few weeks of work can generate lots and lots of weeks of work for coders. So I'm just going to dive into this one issue that was created for the point component. The point component is basically that card, the representative for that card that you see. And so we just take that and break it down. Here's the props that go into the component. This is a string grab out of Figma. Here's the link to the Figma for this particular component. This was a more complicated component, so it's got more details. But this is all the stuff that was given to one of the volunteers to build this component. Can you make it a little bigger? Yes. All right, and this is all on GitHub, so you can go look at it later. And again, we're rushing through things. And anyway, and this is the code. This is the React code for building that component, just the point component. And as we sort of work on the code, we include links to the issues that were worked for this, so that you can refer back to it if you ever come here and have to work on it again. And this is just a simple React component. Well, a little bit more complicated than simple. Also, we're doing React JSS, so we have all the CSS styles in here. And the thing that really makes this work with a volunteer, a volunteer developer community is that we're asking volunteers to create the component, but also create the storybook that goes with the component to test it out. How many people have heard of Storybook? All right, yay. Okay, and for the rest of you, it's a surprise, right? Great. You're learning something new. So the advantage of Storybook is that as you're building this React component, you build the sort of the test case for this as you go. And it makes it really easy in real time to build the component. It's evolving on the screen as you save the code. And you can sort of recreate your test cases over and over again really quickly. And so here's like one case for the point component. Here's the selected case. Here's the disabled case. Here's the case with a lead button in it. There were a lot of cases. This was sort of, this is the kitchen sink component. And so I want to show you what a story looks like. It's basically import the point, which this is the component that you build, and skip this because this was input into one of the tests. But the basic format for Storybook is export this object, which says this file is testing the point component. These are default args to pass to every test for this component. And then here's we had that primary default case. So we're writing a test case. It's called primary default. We're passing in this arg called visual state, and that's it. And then it just renders like this on the screen, and you've got it all going. And I want to show you one other case. This is the button component, and you can also use this play function to interact with the test. So this is testing that somebody has clicked on the button and that you're getting the right response. So you basically, in this play, you pull in the canvas, you simulate a user click, and you look for the result, and then you check the result to make sure it's what you want. So this was all done, for each component, one component at a time. And then when you get to the end, we've been building components, and we build higher level components on top of the lower level components. And here we're to the point where we're pretty much starting to integrate everything into the full application. So I talked to you about the steps. So the first step was to basically answer the question. And this is all running on the browser. The server side is something else that can run separately. Obviously you want them to run together at some point, but this is so great for building this and testing it, and dividing the work up among a lot of developers. And so here is the case for grouping points together. And you can see it's sort of got my previous data already in there, but you can group the points. And then after you're done grouping, did I group the points? All right, let's reset this for a second. All right. Of course, it's a live presentation, so the demo might not work, right? All right, here's all the points. And so I was talking about the grouping step. And this is why React is great. This isn't a forum. This is like an interactive exchange. And so we're grouping these things. I'm saying this is the one that goes on top. And then we're done. And then we go to the next step. And this is the ranking step. So you're sitting around and you're looking at all these issues and you're saying, I think these are most important and neutral. I think I missed the most. There we go. All right. And so now you can go to the next step. And so this is that why is it most important part that we were talking about. And then why is it least important. All right. And so here is the discussion part where you're basically listening to the people around the table. But here we're saying these are what people said. Pick what you think is the best argument for why it's most important and why it's least important. All right, and down here, what's the best argument? All right. Okay, it's not, I got to show you this, that was great. It's not letting me go to the next step. I don't know why. But such is the life of trying to do live demos. But in the end, what I want you to get out of this is that we can make online discourse productive. We just have to build that rather than build what we've got with trying to make money. So we've got to build it that way. And it's not going to be a for-profit thing. That's why NCIV is a nonprofit. And React has been awesome for being able to make all these components and make all this interactive. And Storybook has been great for, not just testing it, but being able to divide all this work up and have lots of different volunteers work on it and piece it together and have something to go. So with that, I'm going to open it up for questions. I don't know how I'm doing on time, so you can tell me just how many questions there are yet to be.
Everyone give David a hand. Thank you. Go ahead and raise your hand if you have any questions.
So you mentioned you have 1,000 online. What procedures do you have in place to prevent bots from being 900 of those 1,000?
At this point, by being really small. But we do have, we do have sort of a login and creating an account space, and we'd like to get to somewhere where we can do verification. And one of the things that we actually want to do is verify your actual physical address, because we also want to know how many people are in each state, and we can do, and we can do similar discussions for, like, what's the most important problem in the state, or what questions do you want to ask your mayor. So the location, what's your address information is relevant, but definitely it's a concern. We're going to have to address it. But right now, our biggest risk is, proving that we can get 1,000 people.
For your concern about identifying who's in which state, you can use geolocation to say where they're coming from. VPNs and other things can mask that, and cell phones will misreport, but that'll get you a first order approximation.
Okay. Well, and we can also, there's the Google has the government information database. I forget what it is. So you can take somebody's address and look it up and find out what political districts they're in for voting and things. So I want to use sort of a combination of all that. If you say this is your address, are you at that address at least sometime? And but yeah, it's a problem, and it's something we're going to have to work with. Anything else?
Any more questions?
I think that's good for time. So again,
Okay.
thank you, David.
All right. Thank you.
Everybody give a warm welcome to Keith. Who'll be talking about Arcane.
Mic check. Anybody hear me? Okay, I think that's me there. All right. All right. So I'm going to admit up front, I am nervous because this is something I've been working very hard on for 3 months, and I was misinformed / probably misread the time that I have to present this, so I'm going to be going quick. That being said, I'm going to try and do my best. Thank you. First and foremost, does this work? No. Okay, cool. So I'm presenting Arcane, which is AI for makers and person-scale problems. That's going to make more sense as I talk about the inspiration behind this. But in order to do a good presentation, the 3 things you have to hit on immediately is you have to tell the audience who you are so that they know that, why they should even be listening to you. You have to tell them what you're going to be telling them, which is going to be self-explanatory in a sec. And you have to tell them why they have to care. So let's cover that basis before I dive into the more particular bits. So who am I? I'm Keith. I'm also Half Shell. You'll see me on Discord a lot. I'm in the DEVx Discord all the time. My expertise is AI and robotics. That tends to be what I care most about. You can message me anytime to talk about maker projects, AI, robotics, but I also do free resume review, free practice interviews for software engineers, so you can reach out to me about that. And I also do free-ish startup consulting. My rates start at a beer, goes up to a bottle of bourbon, depending on how much I'm doing for you. Some of you also already know me from SDX, which is another group where I run the paper club, where I cover in-depth AI topics. The next club is February 18th. I'll be covering the DeepSeek R1 paper, hopefully not talking as quickly as this. And we're actually, I just got texted, we're doing a hackathon on Saturday sponsored by OpenAI. We're going to play with the O3 model, so do check out SDX if you're interested in working on AI stuff. Great group. Now, before I talk about what Arcane is, I need to answer the question of what is an agent. This is all the hype cycle right now. It's in all the news. The problem is that there's a lot of different terms that are shooting around there. And the reason is because some people that are talking are researchers, and some of the people that are talking are charlatans trying to raise money. So it's difficult to see what the actual term is going to be. I am not going to do a debate on what the definition is. I'm just going to say that for now, the definition of an agent is a simple AI capable of completing a singular task that is really good at, right? That's the only definition I'm going to be using today. But why are agents getting popular? Well, it turns out that those models that we are saying are going to lead us to AGI aren't really good at complex tasks past a certain level of complexity. Similarly, if you give a model too many tools, most models right now is about 4 to 5 tools, then if you go above that number, they get confused, forget how to use the old tools, and they just can't complete simple tasks. So the approach that we're doing right now, that you're seeing across across the startup world, are small individual AIs that can do one thing simply well, and then getting them to either collaborate or work together in some possible way. So what's Arcane? It's yet another Pythonic agentic framework. But why is this one different? Why is this one something that I care about? Well, it's designed not for giant corporations to run their latest startup or their web scale thing. It's designed for people to make quick prototypes or people to make task-solving AIs. I'm specifically targeting the maker market with this. It's built to be used by non-professional coders. I want people who aren't good at coding to be able to pick up some simple Python and make a Python project or make an AI project by the end of the weekend. The design philosophy is to make it easy to share and build upon, and I'm going to expand upon that in a second. And it's not beholden to any single platform. It works with all of these models, and I'm going to be adding more. DeepSeek is the exception. I was going to add it last night. Their API has been down for 3 days due to DDoS attacks, and everything's fully open source. So what am I building with this? Well, I'm going to be hunting for a job soon, so I'm going to have an AI that scans job postings for me and let me know which ones are actually worth looking at, research the company, that kind of thing. I dream of having a personal research AI that I can email, and it's going to reply back with a nice written article about the topic that I'm interested in. I love to learn about things. I'm building a business leads generator for my friend who runs a small business who wants to basically use human evaluators to find potential leads to sell their journals. And well, that's something that he has down to a process, and we're going to be trying to use AI to do that at scale. And of course, my wife loves this one, private conversational AI that can answer my questions, but also make fun of me. I don't want my chatbot to sound like it works in HR. I want them to have some personality. But that's what I'm building with it. That's not necessarily why you should care about it. So why should you care about it? Well, I want to actually take a look at the Arduino and the Raspberry Pi. Who here has used these things before? Yeah, great. So you guys know about this, but what you might not know, and this is dating myself a little bit, before the Arduino came out, getting into embedded hardware was freaking hard. You had to drop hundreds of dollars on the programmer, hundreds of dollars on the program board, and then you had to pay for the IDE and the right to use the language to program some of them. Arduino completely changed that. It made it so that even grade school children could start to make their own electronics. The Raspberry Pi took that a step further. And from this, we got the 3D printing revolution. A ton of new hardware companies popped up because embedded hardware could suddenly be something you do on the weekend. People were making technology their own. Arduino had this great concept as well, where you could basically produce shields, plug it into the Arduino, and people that knew what they were doing were building components that you could just plug in and use really easily without having to be an expert in embedded electronics. And that was a great idea. So open hardware ignited a new wave of electronics and inspired millions to make personal scale tech. We need the same for AI. We need frameworks not designed for companies, but designed for people to do their weekend project. So basically, that's my mission statement. AI should be for you and by you, and it should not be built to extract your money. So that's a lot of talking. Let's actually dive into the code. This is Arcane in action. I create a Wikipedia search object, which is just a module. I pass it an LLM, which will handle all the stuff for you. I ask it the question, where was Einstein born, as a function, and it returns the result. That's it. That's the whole thing, and it's designed to be that easy. Now, you might be saying, well, okay, it's just asking an LLM and you're printing out the answer. It's not. It's actually specifically trained or prompted to know how to search Wikipedia, read the article, and pull the answer from that. But you don't have to know all of that in order to use it. Another example on this one, research the applications of LLMs to robotics, one of my personal favorites. This web searcher agent here, what it will do is, given the topic query, generate n amount of possible queries that it could find the information from, go to DuckDuckGo or Bing or Google, search it, look at the results for all the web pages, from that decide which web pages are worth reading, go to each web page, summarize their contents, then combine all those summaries to create an ultimate summary that you can read. It takes about a minute. But that's a lot of stuff happening at once that you might not necessarily need to know the down and gritty to, but you can start to build stuff with this really quickly. And the primary goal of Arcane is that if you can call a function, you can use this library. And if you really know what you're doing, which some of you, since you're here at a DevX group, I'm guessing you can do way more complex stuff, sure. So the idea that I'm building on is I want basically AI coding to be like Legos. People can play it together, and the real experts will create great cathedrals while everyone else is making fun little car toys they can play with. So terms I'm going to be using throughout is a tool. A tool is a function that does something with some extra niceties. We'll see what those niceties are later, but just think a tool is a function. Keep that in your mind. We have an agent. An agent is a tool that has an LLM. That's it. That's the main definition there. Always remember, all agents are tools, and that's important to remember for a little bit because we'll see why. There are different types of agents. Iterative agents can call itself repeatedly to try and refine something. And then finally we get back-end agents, which are agents that can call tools. We'll dive into that later. But you start to see where you can build up on this. And a back-end is the term I use for just a framework for handling the tool calls. This is taking care of all the parsing, the prompting, and telling the LLM how to actually handle the tools, what they are, how to call it. And then basically once it outputs something, it'll parse the output to separate the tool calls, call them, feed it back into the LLM. All that's being handled for you. And then there's a word you'll see thrown around a lot called context. That's state that's tracked across executions. So everything I'm trying to make as simple to use and compatibility over everything else. That's the philosophy of everything I'm trying to aim for here. So again, tools are functions with extra capabilities. They have a name, a description, arguments, and a result, and possibly examples. They do something. So let's take a look at one. So this is the tool that we used earlier, or one of them, Wikipedia search. If I print the name of it, it's Wikipedia search. If I print the description of it there, if I print all the arguments, it's going to print that there. The reason this is important is because the way that you tell LLMs how to utilize things is through text. So by programmatically formatting the tool with all of this information, I'm able to format it exactly the way that the LLM wants when I go to do it. That's what the back end is doing. So again, here's an actual tool that we're going to make from scratch. Is that I basically just import tool, I set a name, a description, a set of arguments, and I say that this is the function you're going to call when the tool is called. And then once you have that information, you can go ahead and pass that to an LLM or utilize it with anything else. Here's the tool that I called earlier. You don't have to worry about reading it because it's mostly filler text. 90% of this is just a description of how it works to the LLM. And then the actual function call to the Wikipedia API is that line right there. That's it. And then that's going to find what pages are related to your query for the Wikipedia agent so that I can go and query that page later. Most of this is just describing what is working. And the reason for that is because you want to describe to the LLM how your stuff is working so it can utilize it in the actual stuff. Maybe you already have a function, you don't want to use my tool, that's cool. There's a decorator that will automatically do that. It will actually, if you utilize standard Python comment patterns, the most popular ones, it will actually parse your, in code, it'll parse your function and your type hints to pull out the description, the type explanations for the different variables that are for parameters, your return type and everything. So it'll take care of all the writing for you at that point. All right, but you're mostly here for the agentic AI stuff. So what about agents? Well, agents, there are two rules. You gotta basically tell the agent what your prompt is, telling it what it has to do, and how to extract the output from the LLM's response into the form that you want for your function. So here's an example. We just have a simple agent. Again, you'd have the description, just like a tool would be. The only two things you need to do on top of a tool is you have to prep a function called prepare prompt, which just returns a giant string prompt of what you're trying to tell the model to do, and extract result, which is you're just trying to take from the string response of the LLM and try and output with whatever it is you're trying to return there. Another way you could do it if you don't want to do the object-oriented approach is I just have this thing here. You can pass them in as functions as well. And it's just really simple to set up and use. I know I'm going quick. Sorry. Iterative agents we talked about. So, but we want to use tools as agents. So we got to talk about backends. So we talked about, okay, who here has used React before? And I'm not talking about the JavaScript framework. I'm talking about the LM approach of prompting models. One or two? So this is basically an approach where you tell models that given a task, it's going to complete a thought. That thought is going to then be analyzed by the LM to determine whether or not it's going to create an action that calls a tool. That tool call gets returned, and then the LM says, based off the task or the question presented to me, can I utilize the information from the tool call to say that I'm done for an output, or do I still have more work to do? And then it calls back the thought. And this process continues until you have an output. So this is a back end within Arcane. Similarly, a lot of the open model, or a lot of the model services have built-in tool calling, so we can just plug right into that. We don't have to worry about the parsing and all of that. This one I like a lot. I built this for the hell of it. This is the Python environment backend. You give it a task and it generates a set of code for you. That code is executed inside a Docker container with a socket connection to a special server that is controlling all of your tools, so it can call the tool, return the result, and continue executing just like a function call as if it was local. The resulting code output/exceptions get thrown into a separate agent that reviews and refines it based off a judge and determines whether the task is done and can return a result, or if it has to generate more code based off of the refinement suggestions, and this cycle kind of continues forever until your stuff is done. And then I'm also working, there's also a chatbot backend as well, so you can have a chatbot and several lines of code and then just only have tools. This is a good example of how it works currently. You ask a question, it determines if it needs to call a tool. If it does, it calls it. Then based on the conversation and the personality that you prescribe to it, it's going to go ahead and generate the response for you. And then I have several other backends that are in the work that I won't talk about right now. But the point is that backends do a lot of the work for you. As long as you have a backend prepared, it will automatically know how to handle all the tool calling, tool parsing for you, and be able to handle that. So basically, you just have to experiment with which backend. But once you find the one that works for your task, you can start building like Legos everything else. So making a backend agent is super easy. All you have to do is create an agent, just like you normally would, and then you have this one function, prepare for backend, which takes your input and then outputs a set of commands or a set of arguments that the backend would expect. That's it. Once you do that, you have all the parsing capability of all the backends and all the tool calling capability there. So this is just another example. This is the Wikipedia search agent that I was talking about earlier, where all it does is take the argument of question and map it to task, and you're done. And the backend will handle everything else, and it will call all the tools for Wikipedia for you, and it will know how to do that. All right, but why am I excited about this? I keep talking about Legos. The original name of this project was Composable Agents. This is where this idea kind of expands out. So I have a Wikipedia agent that does one simple thing. It scans Wikipedia, summarizes the article. I have a web search agent. Well, why can't I have a research agent that knows how to call these? Because this is a tool. So if you follow that pattern, you can go from a very simple tool and build up to more and more complex behavior to the point that, yes, this research agent has a simple job. It knows how to call 1 to 4 tools, but those tools inside have tools within them, and those are doing complex tasks, and you get increasingly better behavior as you do this. So how do you do that? Well, that's where we have Flow. Flow is basically a set of tools designed to chain together agents and tools in ways that make it useful for you. For instance, the linear tool just allows you to chain responses of agents into each other, or you can throw some functions in there too. So if you need to do some formatting. So you just say, okay, linear, name, description, just because it's a new tool, and you pass in a list of what tools you want to execute in order, and you're done. Conditional, self-explanatory, if, then, or else, same idea. And we have retry, self-explanatory, it'll retry based off certain parameters. Branching is that you have one input, but you want it to fire off to different agents. We have a parallel list, so you have a list of inputs, and you want multiple agents to fire off at once for that web searcher. That's what we had, so you had the list of websites that you want to scrape. You pass that into a parallel list of summarizers, which then on the fly will summarize all of them in at the same time. On air, obvious, fire and forget also there. And there's several more, but I'm not going to go through all of them. All right, now I talked about state. The one thing that if you worked with a lot of these branching agents, you're really curious about state, because that is something that is kind of maddening to do. This is the live demo portion, so this is where everything will crash and burn. I have a simple thing. This is readable, right, guys? Yes. Okay, so literally I just import my Arcane stuff. I have a little quick start function where I'm telling it, boot up the spellbook socket. Spellbook is the cool name for the very simple thing. We have a web searcher that I created. I'm telling it it's OpenAI. I'm asking it that same question we saw earlier, and I'm going to print it. And I'm just going to keep alive until I send it the kill signal. All this is built into that. One thing I am going to warn all of you, I am not good with CSS, so I apologize. All right, so I'm going to just execute that. And, yeah, it's over here. connect to it. And this is the context that's being passed around. This is all being done for you in the background. That tool, that web searcher agent called 9 separate tools in order to complete its task. I can dial down into exactly what it was doing, what it returned, and what it was thinking at the time throughout that entire process. So for instance, this is the final output. The latest trend in robotics involves those, so on and so forth. If I come to the parallel list, I'll see that, okay, I did this argument here. Here's all the different summaries it was fed out. And then it simultaneously starts summarizing those summaries, which in turn was summaries from different websites and so on. And all this can be debugged here. You can also execute them from here so that if I wanted to, I could say, fire off another search. And that's all handled right here in Spellbook. So this is basically the debugging tool to make it simple, simple, simple for you to utilize these agent stuff. So that's how you handle the context and the state. So what tools are available right now? These are the integrations I've already programmed, and you can utilize to start building up your stuff. You want to send an email, a text message, we got you covered. Web searching, local map search, so this is like, I want a coffee shop near me, we got that covered. Wikipedia, as you saw, we can check the weather. We can read and convert PDFs to Markdown. Websites we can convert to Markdown and read for you for scraping. We do get stuck by CAPTCHAs. Summarization, labeling, we have chat available, some vector and RAG stuff. I want to Arduino integration, home assistant, so we can get it to controlling people's smart homes. Playwright integration for better website control, database querying, so that we can get it to the point where you can talk to a database and build out that stuff. So these are all tools that are already done or in the works that you can utilize, and I really want other people to start building out other tools for stuff they want. Now, connectors are basically ways to run your agent. Now, one of the things I kind of realized thinking about it is like, wait a minute, the integrating of the agent to services that you actually want to trigger off of is going to be really difficult. So we had to handle that for junior developers or hobbyists as well. So we have stuff like the schedule, which is you can just set it up to fire off on repeat at a set interval that's kind of human language. It's easy to set up. We have an inbox feature, which is you can have it respond to, connect it to your Gmail, have it respond to all your emails or ones that are just from yourself, and then you tell it what agents are going to get past the email. So you can just go ahead and build out things that respond to email. We have stuff that responds to RSS feeds, really easy. This is all you need to do to set it up and pass it to the different tools and agents, and it'll just go ahead and trigger. If you want an API server, you just pass it the tools and agents you have, whether or not you want authentication for it, and boom, you have a fast API server ready to go to treat your stuff. We have a CLI tool, so if you have a bunch of agents that are useful that you want to activate in the CLI, go ahead, pass it. This is all the code you need, and you'll be able to call it just like you call Git in the command line. And it'll take care of all the parsing for you and all that stuff. But what's next? Well, more of everything. I want more tools. I have a lot of bug fixing to do. This is an early stage. A lot of capability and features that I want to add, such as a tool registry, some automatic tool generation for to make it easier on young devs to go ahead and build out the stuff. And mostly I'm looking for a community. So if this is something that you're interested in, or you managed to grasp anything I said at rapid pace today, I would very much appreciate if you joined us at the Arcane Discord. You can find it through the GitHub there. Or if you're interested in building AI stuff, let me know. And utilize this framework. Let me know how it works for you. That's it. What can I answer? Yeah. Question.
Hi. Thanks for the presentation. So from what I'm getting at is in some ways agents are just like pre-generated AI prompt engineering?
To a point. So these agents are, so the prompting is pre-generated for the back end to do like, this is how you think, but it's up to you to explain to the AI what you want it to do and some examples of what you want it to do. So it's up to you to handle the last mile prompting. The reason for this is that I want it to be so that if you are a complete newbie at programming and you understand some Python, you can explain in human English what you want the agent to do, and you're still able to get out a pretty good result. But if you are an expert developer, you can still go in and control the exact parsing, how it's utilizing, what kind of pattern is it doing in the background to get the LM to maximize its performance. So all that is still stuff you can still control, but it's also with a simple interface so anyone can use it. Does that make sense? Yeah. Anything else, or?
Any more hands?
Sure.
Thank you for the talk. Great conversation and presentation. So before I ask question, do you familiar with the N8N.io?
What's that?
With the N8N.io?
I don't know that one.
So technically is after workflow automation, but based with the AI. So my question was like, what's the difference? Because they use AI agents for that workflow. So, but if you're not familiar, then the question will be different. Like, so do you try to solve, eventually your motivation is to create AI native workflow for people?
The hope is to make it so that maybe one day Spellbook you'll be able to compose agents, sure, but my goal is not to make it so that it's a no-code tool. My goal is to make it so that hobbyists and DIYers can say, I want to make an agent for a weekend project to automate responding to this kind of email, and do it. I'm not looking for the ability to make the next, Google. I'm looking for the ability to make the next little hackaday.com project.
Thank you, Keith.
Right, thank you.
Oh, keep clapping. Yeah, go ahead. And welcome to our final speaker, Ezekiel. Give him a round.
All right, are we good?
Good, yeah. I would just note that if you turn your head that way, it will go out.
Let me see. Maybe I'll put it closer to me. On the left side.
Or
Okay.
your right side.
My right side. Stage right, stage left. I don't know who I am. Okay, are we good there? It's going to be hard. I'm going to try not to yell at you. I'll use my inside voice. I don't do that very often. And let me set up my computer. Okay. That is something. Not quite what I'm looking for. And my operating system just updated, and I think it's giving me like a second screen.
That's a beautiful background.
Thank you. That's exactly what I wanted you to see. Primary display, secondary. That did something. Built-in display. Maybe instead. I think that it is duplicate. It's at like extending to a second, which I want to mirror. Let's see, let's apply this and see how that works. Okay. And let me open up. Oops. I just closed what I needed. Okay. I'm going to leave this up for a minute. I'm going to be using a tool called Stable Diffusion, and if anyone wanted to follow along, get your laptop open, phone open, scan a QR code or go to linky.easyeasy.win. There we go. You can see it better that way. All it's going to do is it's going to redirect you to a running instance of Stable Diffusion that I have up, and you can play around while I'm figuring it out and try any of the things I'm going to talk about. And I'll introduce myself while this is up so that everyone has an opportunity to check it out. So first off, I'm really happy to be here. Thank you so much for coming today. It's been really cool to see the DevX community grow month after month, and I'm getting a lot of enjoyment about being able to share excitement for projects and see what other people are building. It seems like AI is pretty popular. Everyone was excited about it last event. I opened up Stable Diffusion for a minute, and people were like, "Oh, this is interesting." So I thought I would talk to you about it. And now hopefully everyone's gotten a chance to open up. We're going to be talking about AI image generation, specifically a technology called Stable Diffusion. And I am Ezekiel. I'm going to be giving this talk. I have 7 years of experience working with web technology mainly. A technology enthusiast, AI hobbyist. I just enjoy this kind of thing, and I'm hoping to share that excitement with you. Stable diffusion. I'm not really going to go into how much it works under the hood. I stole one slide from our last presenter, Keith, actually, but you'll see that in a minute. But the main thing it does is it allows you to easily, it's a model for generating your own AI images. And the way it works is kind of like, this is your slide, I stole it right out of your thing. But the way it works is if you've ever used a denoising algorithm from when you take a photo and you're able to figure out what is the photo and what is noise, and you kind of remove some of that noise. This is like a magic version of that, where instead you have nothing but noise, and eventually you get to what the image should be. And that's the extremely simplified way of doing it. I thought I'd start off by just showing you some images that have been generated using AI, so you can see what kind of things you can create. This is really highbrow art, very important and moving in our culture and society. There's also some things that you might not even consider, like this is actually AI generated image right here. It doesn't look like it to me. He has all 5 fingers, so I wouldn't be able to tell. But you also get some really pretty things. Really, I feel like AI art gets sometimes a bad rep for being soulless, but it's just another tool for artists to use if they want to create a scene they have in their mind. This isn't AI art, actually. This is a photo a client sent me. They're a construction company and they were building kitchens, and the company says to me, I want to build a new landing page, and I said, how can I use AI in this, because I want to use AI. And I thought it would be really cool if I had the original sketch, like a blueprint, and I could say, you take it from an idea to reality. And so I used this stable diffusion technology I'm about to show you, to transform from the original actual photo to a sketch of it, to an even more rough draft sketch of it, and you can see all 3 of them side by side. And then on the website, I had it fading from one to the next. A lot of people think of just generating one image, but you can actually alter images or use images as inspiration. A lot of ways to personalize it and make it your own. So this is just one example from the real world of me using this for a client. I don't think we ended up actually using it, but it was an iteration I had. So with my talk today, I have a couple goals. I want to explain to you how you can get started with AI image generation technology. I want to inspire enthusiasm about the technology. And I want to just my goal is to give a very high-level overview of how this technology works. I'm not going to go too far into the weeds. We're not going to go into what makes the magic. I'm going to say how you, as a person with minimal understanding of how programming works, can do it. I'm going to speak to you as if you are someone who is in the realm of programming, so I expect you to understand some, like, what Docker is. But if you don't, that's okay. You'll probably still get something out of this. So some common problems when people start on their journey of generating AI images are they don't have the hardware for it. It's kind of, you need a beefy computer to do it locally. It moves so fast that you can't keep up with it. Or sometimes the user interface, like if you have to do everything in Python or in TensorFlow, like where these models are usually interacted with, it can be hard. So I'm going to be overcoming these problems by using RunPod for compute power. If you open up the link and you're playing around on it right now, that is all hosted by a 20-cent per hour server that I'm running with very powerful GPU. They specialize in nice GPUs and things. I'm going to use a pre-built Docker image to deploy my environment. One nice thing about Docker, it just deploys everywhere the same. So if it works in Docker, it'll work for you. You don't have to worry about figuring out if you have a Mac or Windows or whatever you have. I'm going to show you how to personalize it. I'm not going to go too far into depth because we have kind of a shorter time for talking, but I'm just going to talk briefly about what things you can do to personalize AI art, including LoRa, ControlNet, and scripts. If you want to get in touch with me, that is something, but we're not there yet. Hello. Okay, so let's jump into it. This is, if you load up Stable Diffusion, this is what it would look like. How do we load up Stable Diffusion? RunPod is one option. There's another place called VastAI, which is pretty similar. RunPod's pretty easy to interact with, which is why I often recommend it. But you can sign up for an account. If you've ever used a VPS before, like Amazon EC2 or DigitalOcean Droplet, it's very similar. You can spin up a server that runs something. One cool thing RunPod does is they allow you to deploy an image. So you can see these are examples of different GPUs that you can use. This one is like their private cloud. I always use their community cloud, which is just like community members who offer up their GPU for use and are running the software to do it. And you can see I get things like very good price. The prices here are incredible. If you're, I mean, for most use cases, if you're just wanting to mess around with it, you're probably not going to be using more than a few hours at a time. It's like putting coins into an arcade machine. But if you wanted to do something like training your own model, you need to run it for like 4, 8, 12, sometimes 24 hours to actually fine-tune and train these models. And so using this, you don't have to run it with your own electricity, set up your own environment. You can easily pay for 24 hours at 22 cents an hour and let it train it for you. And so you're able to select one of these GPUs and then select a Docker image. And this one is using a Docker image called Stable Diffusion Web UI, which I can send you a link, or I'll post a link to this in the Discord as well. But essentially this is just on Docker Hub if you've ever used it. People can post different Docker images that are already built and ready to go. And this is, the name of it's literally Stable Diffusion Web UI. And you can run it like you'd run any other Docker image. And once you run it, it will open up just like this. And this is Stable Diffusion. Stable Diffusion, I am able to just type very easily. This is no programming experience needed, really. I can say cat with pink hat. And if I hit generate, very quickly it'll be able to generate an output image that looks fairly decent. It's this might not look like much, but if I took this picture by hand, it would take me a lot longer than just typing the prompt. I think it's pretty exciting. If I wanted to simply change something like I wanted it to be an illustration, I could just type comma illustration at the end. And just like that, I'm able to change a little something. So this is very easy. That's no longer a cat, it's a cat hat. Unexpected results. Let's try generating another one. It's going to start with different seeds. That is a cat wearing a pink hat, and it is an illustration instead of I would have to be a little more specific if I wanted to get something exactly right. But you see how this is powerful. Very quickly iterating between different ideas. There's a lot of settings here that are very basic, and I'm not going to go into those too much. Things like how many sample steps or how big or how many you're making at the same time. But let's say I wanted to do something a little bit different. Let's say I want to know, well, how is the word pink affecting this prompt? Like if I wanted a pink, blue, or green hat, I can easily, instead of just messing with one color, I can use this script function with prompt search and replace and type in pink, blue, green, and I'm going to skip the sub-images. And just like that, when I generate now, it's going to generate not one image, but 3 with those varying prompts. And this kind of gives you an idea of when you're creating images, if you have a certain set of prompts or a certain set of parameters you want to use, because I could not change a word, I could change what model I'm using. I'm going to show you how to select some different models. I could choose different, this thing called CFG scales is how closely it adheres to your prompt in very basic terms. And I can go through and see how all these things affect it to get an idea of how I want my art to look and what parameters I need to pass in order to be able to make it look the way I want to. And on the first step, this is probably the easiest way to personalize something, is you can do a lot of iterations with something, figure out, let's call it prompt engineering sometimes, where you figure out exactly how to make it your own style using these sets of prompts and settings. And now we want to take a little bit further. What if we want to really capture a specific pose? But sometimes that can be hard to do when you're generating AI images. Or what if I want it to be inspired by a certain person? Well, I can take an image of someone, some random person that I've never seen before in my life. And if it'll let me right click. My right click doesn't, there we go, copy image. And then I can take it over and I can pop it right into here. And this is a feature called image to image, which is just the web UI that I'm using to interact with Stable Diffusion. Allows me to pop things in there. And very quickly I can use this thing called ControlNet that will allow me to basically say, hey, before you make the image, look at what this image is and create like an outline, a bit of guidelines to follow, a control net, if you will, to guide how the image is created. And from here, I can say it is very important, and I want to use this control net. There's a bunch of control nets you can use depending on what kind of things you're trying to capture about the image. And I'm not going to go too far into it. I'm just going to give you an example of how it can work. And then inside the prompt, I'm just going to say cubism. Because cubism is kind of like an art style. It already knows what it's looking at, and it's going to generate it from that image. So if I just type cubism, let's see what the result is. Well, that's not cubism, but you can see it's starting to get something. Let's increase the weight of that word cubism. I'm going to increase it to 1.4 times weight in the prompt. And let's see what that looks like. And we're starting to get cubism. We're starting to get some artistic renditions of the image. And you see how easily it was for me. You can personalize a little more to take in one image and very quickly go to something very similar. This is all free and open source, by the way. This is all able to run on your local machine. Even if you don't have it right now, you can run it on as low as a 1060 Ti GPU that I have in my laptop. I can run these easily. Of course, RunPod, it runs much faster. It's easier for demonstrations. So this is a really cool feature of it. Let's say you wanted to go even more in depth, which I'm not going to show a full of this, but so there's something called LoRa. LoRa stands for low rank adaptation. No, low rank? Yes. Low rank adaptation. Keith says yes, and I trust Keith. So when you're making a model, like the big part, you need a lot of data. I mean, like you need millions of dollars and tons of compute power to process all this data and be able to make a model that we can then use. But once you have that model, you can fine tune it. You can pretty easily, with a few thousand pictures maybe, teach it new things. But if you even want to teach it something really specific, like you want to teach it what is my favorite character from Zelda games, Link. If I want him, then I can make a LoRa specifically of that character or a specific style. And to show you some LoRa, I'm going to jump over to this thing called Svit AI. So Svit AI is going to solve another one of our problems, which was, how do we keep up with everything that's changing? Well, to keep up with it, Svit AI is a great place to come. You can view their models. They have some stuff that's not safe for a public audience, but they have lots of models that the community has fine-tuned or trained and made personalized from. And you can choose that model, and you can actually select the image and see what they used to generate this image. So I can click on this little info here. It'll show me the prompt they use. It'll show me any LoRa or what sampler, how many, like all the settings, like the seed guidance and steps they use to generate this image. And this will give me an idea where I can look at other people's work and very quickly get an idea of how to do something similar myself and then throw it into Stable Diffusion and mix it up so I can do it. Everything I've shown you so far also has programmatic API, meaning if you're running this server, you can interact with any of these settings, any of these options for generation using a web API the same way you might hit something externally. And with that in mind, you could easily throw this into your applications just by saying like fetch in JavaScript, fetch this address with these parameters. Okay, let's talk about LoRa again. So when I'm going to models, if I type in something like Link or Zelda, and then I type in, this right here, instead of being a full model, is a LoRa, which is much, much smaller, much smaller in size. It's only 144 megabytes to add on to your actual model, and you can use it to generate pictures of specifically Princess Zelda. And it'll be much better than just using something like ControlNet or a script or prompt engineering to understand what Zelda is. Because you could say cartoon character with blonde hair, blue shirt, standing in a field, and it would get something. But using LoRa, it's been trained to understand that when you say Zelda, you're talking about this character right here. And you can then say, oh, well, what if I want it from an older game or from a different series? And you could train LoRa on yourself. You could take several images of yourself. There's actually a lot of guides available, which I will also include in the Discord if that's something that interests you. A thing called Dream Booth, which has a plugin for this web UI. And it will allow you to throw in a few images of yourself or what characters you're interested in, and then use yourself as a name. It'll know who you are, not like on a personal level, but it'll know what you look like well enough to be able to recreate you. As far as the presentation goes, that's most of what I wanted to tell you about today. I wanted to try and keep it short, wanted to try and show you some of the power you have with this and what you can do. There's also, like I said, linky.easyeasy.win. You can interact with that. I'm going to leave it up for the rest of the day. You can play around with it for free. And it's very powerful technology. How am I doing on time? Good? Okay, I'll take some questions.
Go ahead and raise your hand. You got one?
So you had an image of a person. If you had a specifier like oil painting, watercolor, would it do?
We could try it. Let's see what it looks like. Well, I think a demonstration's worth 1,000 words. Let's do, instead of cubism, oil painting. Thank you for the question, Edward. It's a pleasure to hear your thoughts.
Quite curious.
And it begins to look like an oil painting.
Okay.
We could try and see how maybe instead I want to do impressionist, IMPRESSIONIST. And I could throw that in there instead. That's like its idea of an oil painting. And I could always try and find, now it's doing an impressionist painting, and I could always try and find more specifics on like LoRa about oil paintings so that it really understands what an oil painting is. But for just a general model, I feel like that does a pretty good job. I would be happy with it.
Beautiful. Any more questions?
If you use the in-paint, can you show that?
Oh, you want me to show in-painting? Yeah, I'd be happy to show you in-painting. So the way in-painting works is, and there's a lot, I'm showing you the tip of the iceberg, how you can get ready, how easy it is to get started. But all these settings have like, the barrier for entry is low, but the skill ceiling is extremely high. So what in-painting allows you to do is, and I can send it to in-painting. So if I do copy image to in-paint, la-di-da-di-da. What I can do is there a way? I can draw specifically where either I only want it to do a certain part, or I want it to do everything but what I highlighted. So like if I highlight this part right here, and you could also programmatically add a mask to the image, but if I do this one right here, and then I say in-paint not masked, and then I generate, it'll do everything the same, except it's only going to do the area I did not highlight. So you'll see the eyes now are exactly the same as the actual picture, and then everything else around it was kind of painted over. And you can do this. This is like one example of doing it, but you could also do it like to add a ship in the background. You could say, oh, you have an image of yourself and you just want to add like a pirate ship in the background of your lake or something. And I've seen people do that, where you could just draw on a small part. Another powerful tool. Any other questions? Raise your hands. Don't be shy. I'm friendly. I don't bite.
I had
Please.
one question. What were the how big were the default models that comes with this program to run on Docker? I know I've done some image generation, stable diffusion stuff a while ago, and it just sucked up a lot of my disk space.
Great question.
What's the
So
default
models can be anywhere from 2 gigabytes to like 6 gigabytes is normal, 2 to 6 gigabytes per model. Of course, if you want to be experimenting with a lot of different models, you're downloading a lot of different things, then it will readily take up available space. But what I do personally is I'll just delete a model if I'm not using it, because it only takes like 20 minutes or so for me to download a new one if I need it. And then I have a couple that I use for primarily and leave around. And when I compare it to like playing a video game, the video game takes up like 20 gigabytes versus 6 gigabytes for this. I'm happy to have it. There are And also, though the models can be like 2 to 6 gigabytes in size for your base model, a lot of these LoRa or additional things are much smaller, like a few hundred megabytes, which in today's age is nothing. Thank you for your question. Thank you for being my sample image. I didn't even ask you for it, but open source, exactly. Any other questions? Please. Or wait, I'll let someone bring you a mic.
Just a comment. There's also stable diffusion video, which you can use in the same interface.
So the comment that he just brought up was that there's also stable diffusion video, which you use the same interface. Yes, absolutely. You can use the same technology to generate video. There's several strategies for it, and you can also use so many plugins that are community made to do things like there's Tortoise TTS that has text to speech. You can actually write text, then it'll generate speech that sounds pretty human or lifelike. There's Sumo, which is able to generate songs from a script about song and stuff, and you can generate that and then put it on your video. There's tons of, like, if you can imagine it, someone's probably doing it. It's a beautiful world to be in. Go ahead.
Oh, okay. I know this is different, but let's say you had a video and you want to remove noise from the audio.
Yes.
Would you use a tool like that to do that?
So the question was, if you had a video and you wanted to remove noise from the audio, would you use a tool like this to do that? I personally wouldn't use this tool. This tool is primarily for image, video generation. There are plugins. Maybe someone made a similar thing for audio removal. But when I think of audio removal, I think of like Audacity and other like audio program tools.
Well, specifically to remove background noise, to clean up the audio.
So specifically to remove background noise, I would use Audacity. Audacity is great for that.
Really?
Yeah. You can get a noise profile of what the background noise, which this is not what our talk is about, but just let you know, I could show you, but afterwards we'll check it out, yeah?
Everyone give Ezekiel another round of applause.
Thank you so much. I also wanted to say I just had about 8 hours of my weekly time freed up. A client is no longer in need of me. So if anyone needed someone for consulting and it was a smaller project, I'd be happy to talk about that. And I'm very friendly. Don't hesitate to say hello. Thank you so much. Thank you. I don't know where I am.
I know where you are.
Thank you. I can hear myself on the speakers. Oh, thank you. That was nice. Oh, no. I'm just going to set it like that. Thanks again, everyone.
And let's give another hand for all of our speakers. So, now is a time where anyone can get up and share some announcements with the community, projects, ideas, event or activities, or your current Roman Empire, which I still have yet to grasp a meme of that, or just introduce yourself. Takers, we got one.
I'm Rick. I'm one of the co-organizers of a hackathon that's coming up next February the 19th. It's called Hack Your Heart Out, some reference to Valentine's Day. But there's a bunch of companies supporting it, Replit, Neo4j, Unstructured, Qualcomm. And this is going to be, I think, at Qualcomm February 19th. So anyone who's interested, it's helping other startup companies build some open source project. It's like a 4-hour kind of sprint type of thing. Should be pretty fun. Get to play with graph databases and AI. I'll drop the link into the chat. Probably the best way, right?
Awesome. Anyone have any other announcements? What we got? Good question. Does anyone have any good desires for presentations? Cool. Any more announcements?
just a question: who would be interested in a presentation on nuclear fusion? Because I'm working on that anyway for another conference. And well, I'll ask: is there an interest in something like that? Really? Okay.
Unanimous. Everyone wants to hear nuclear fusion. Okay. So, thanks guys for coming. Go ahead and follow us on our links on our website, or join our community, our Discord community, and check out our event calendar also on our website. Oh, and as a note, everything here is free, but we accept donations for pizza and stuff. So go ahead and snap that if you wish. And thank you.